Okay, in this lecture, we're going to have a very high level look at different AI models so that you understand them in concept and you can have an idea about which model is the right model for your specific needs. And so that you're not completely bewildered if you're in a meeting and people are talking about different AI models, you'll at least have some understanding. This course isn't designed to help you to learn how to actually implement these models, but I do want to give you the overall high level understanding of them so that you're familiar with them. Okay, starting with supervised learning, which means you have labeled data, or in other words, you've got data with some annotations that indicate the correct output or category associated with that data. For example, you've got loads of pictures of cats and dogs, and you've actually labeled them to say which ones are cats and which ones are dogs. The model then can use that data to learn the difference. Then you take that data, you split the data into a training set and a test set. You'll use most of the data for training, but you'll withhold some of the data for testing. And then what you'll do is you'll take that test data without the labels, run it through your trained model and see what it came back with and compare the model's results to the labels that you've got, which you know is the ultimate truth, and see how well the model did. You can use this method to predict house prices. So suppose you've got data on various houses, including features like square feet, number of bedrooms, distance from the city centre, and of course their house price. Linear regression can be used to predict the price of a house based on these features. So supervised learning has two subcategories, regression and classification. You want to know what the layman's description between the two is? Well, regression is used to predict a value like price, size, weight, etc. Basically a numerical value, and it could be anywhere within a range. Classification is sorting into classifications or groups. So for example, is this email spam or not? Or is this a cat or a dog? Let's look at regression a bit more. Regression is used to understand and quantify the relationship between a dependent variable and one or more independent variables. In simpler terms, it helps us to predict the value of one of the variables based on the values of the others. In our house example, the variable we want is the price estimate, and that is based on the other variables such as the size, square footage, the number of rooms, the distance from the city centre, etc. So common types of regression model are linear regression, which is a line through the data known as the plane of best fit. These charts show the basic idea, but remember we are dealing with more than two variables. Linear regression can handle multiple variables. The other popular regression model is the decision tree, which looks something like this. Each square is called a node and represents a variable. The more you have in general, the more accurate the model will be. See how each is a decision with a yes or no that moves it to the next question. Next is random forest. A random forest is basically a bunch of decision trees, hence the name forest. It's random because you create different versions of the dataset, selecting random parts of it in a process called bootstrapping. Then you use that bootstrapped dataset to create a decision tree, selecting random variables from it. A fair bit of randomness in this process. Do this a bunch of times and you have lots of decision trees, creating a forest based on random selections of the data and variables. Then you run your data through all of them, tally up the results, and see how many resulted in a yes or no prediction. The majority wins. Using a variety of decision trees makes it more effective than using just one. Next are neural networks. Neural networks are inspired by the brain. They have an input layer and an output layer and a bunch of hidden nodes in between. This is where deep learning happens. See my video on the differences between machine learning and deep learning for more on that. Let's look at the classification models now. In classification, supervised learning, the algorithm learns from labeled data to classify new and unseen data into one of several classes or categories. Classification models include logistic regression, which is used to classify between two groups. Linear regression itself isn't particularly suited for classification tasks. However, it can be used by using a threshold. This involves applying a threshold value to the output of the linear regression model, and if the predicted output falls above or below that threshold, you can then classify it into two categories. Next are support vector machines. Support vector machines are used on more complex data with more data features, and it's better at dealing with outliers. Used for image recognition, they still only output binary, true or false, yes or no outputs, but they are strategies that adapt them for multi-class classification and for image recognition or handwriting recognition, etc. Another is naive Bayes. Known for its simplicity, efficiency, and surprisingly good performance in many real-world applications, naive Bayes applies Bayes' theorem to calculate the probability of something belonging to a specific class, allowing you to calculate the probability of something being true or false. It uses label data to learn the probabilities. Classification can also make use of decision trees, random forests, and neural networks. Now on to unsupervised learning. So what do you do if you've got loads of data but it isn't labeled or already categorized? Unsupervised learning is your answer. It finds hidden structures or relationships between the data itself. It's great for anomaly detection, which helps with fighting fraud, or for recommending content in things like YouTube, which is based on what you like and what others like you like. It's also used for large language models like ChatGPT, and for customer churn predictions and more. Models in unsupervised learning include clustering and dimensionality reduction. Okay, so clustering is grouping data based on patterns and is used in fraud detection, customer classification, and documentation classification. There are different methods for clustering, including k-means, mean shift, hierarchical and density-based clustering, and for dimensionality reduction, which basically means reducing the numbers of features in your dataset via feature elimination or feature extraction to preserve the most important information. One popular method of doing this is principal component analysis. By reducing dimensionality, you can improve the performance of the machine learning algorithms because you are reducing the amount of data that you're training it on, so it's got less data to actually compute. It also helps with visualizations, making data easier to visualize using techniques like scatter plots or heat maps, allowing for better exploration and identification of patterns. Of course, the less data features that you've got, the less cluttered your visualizations are going to be. There are other advantages to dimension reduction. It's a bit out of scope for this course, but if you are interested, I'll put it up on the screen now and you can read it at your own pace. Just pause the video. Okay, there you have it. That is a very quick and high-level overview of a very complex topic. The aim of this video was to introduce you to the main concepts of machine learning and demystify some of it. You've also picked up some terminology, so hopefully you won't feel too intimidated if your colleagues bring up terms like support vector machines in meetings. Explaining these models in more depth is out of scope for this course, but you can always head to YouTube and see thousands of great videos that have been made to explain these models in more detail and in really clear ways. I do encourage you to watch a few of these so you have a better grasp of the context of how AI models work. It's also important to know because you need to know what data you need and what it can be used for, as well as the AI model's limitations.